To look at what is our lesson today, that is the sum topic, the law of conservation of linear momentum. And I would like by the end of this lesson that you are able to state this law of conservation of linear momentum. And again, you should be able to derive, you should be able to explain where we are getting this law of linear momentum. Then again, we are also going to look at collisions, and we are going to look at two types of collisions. So again, by the end of this lesson, you should be able to state the two types of collisions and also to explain them. So I want to explain the law of conservation of linear momentum. I want us to derive it together, then we are going to state. So I want us to consider two bodies. Consider the following. Here we are having two bodies. We can call this body A and we can call the other one body B. The mass of body A, we can use it as M1. Then the mass of body B, we can use it as M2. So we have these two bodies which are interacting along the same path. So we have this our path. This is a horizontal surface. So the bodies interact along the same path. They interact along the same path. Now I want us to have this is the first body A, then we have the other body B. Let's say that this body M1 initially is moving at a velocity u1, that is the initial velocity, and the other body M2, body B, is moving at an initial velocity u2. Then these two bodies collide. Let's say that the velocity u1, let's say velocity u1 is greater than velocity u2, and therefore when they collide, after collision, we'll have body B moving at a higher velocity than body A. So after they have collided, we are going to have the following. So we have them colliding or interacting. The two bodies will first interact over a short time. So we have M1, M2. This is body A, body 2. So here it is during the interaction. Here we have the interaction, during interaction. Then after they have interacted, we'll have them this way. After they interact, we'll have now body A moving with a velocity v1. The mass is still the same, m1. Then we have body B moving now at a velocity v2. We held u2, now it is moving at a final velocity v2. That is after collision. This is now after collision. Now something that we should note from the Newton's third law of motion, when this body A exerts some force on body B, again body B will exert the same force on body A, but the force now will be in the opposite direction. So the force exerted by A will be equal to the force exerted by B, but in opposite direction. And we are saying that if we take that the time for interaction, let's take time for the interaction to be t seconds. And we are saying that if body A exerts a force on body B or on mass B, on body B, again B will exert the same force on A, but in different direction, because we say that for every action there is an equal and opposite reaction. So when it exert a force, let's say of 3 newtons on body B again will exert a force of 3 newtons, but now in the opposite direction. So time for interaction, we are taking it to be t seconds. So if a body A exert a force on body B will also exert the same force on A, but in the different direction. So if we take the force, to be F, if our force is F, it means that the impulse, therefore, will therefore be given by that force multiplied by the time of interaction. So this will be the impulse. So impulse on body A, let's say on body A, the impulse will be force multiplied by the time of interaction. Then for body B, now we are saying that it will exert the same force but in opposite direction, and therefore here the impulse will be force, in this case in opposite direction, so it will be negative Ft. In our case here, during this interaction, we are considering that no momentum is lost, no loss in momentum. So you need to know that in this case there is no loss in momentum. There is no loss in momentum. And therefore, we are saying this is the impulse on body A and the impulse on body B. And therefore, it means that if we get the total for the impulse, we are going to have the following. That is for body A and for body B, we are going to have Ft plus negative Ft, which is equal to 0. And because we know very well that impulse Ft is given by the change in momentum, therefore it means that for this body A, we know that the initial momentum, the total initial momentum for the two bodies, the total initial momentum, for the first one we have m1 u1, for the other one we have m2 u2. Then the final or the total final momentum, that is after collision, we are having the same m1 v1 plus now m2 v2. And because we have seen clearly here that when we add the 2, that is the impulse, that is the change in momentum, we get 0. Therefore, it means that the total initial momentum m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. This is what it means, because we have seen that the total impulse will be equal to 0, meaning that even in this case, it means that Ft for this body is equal to Ft if we take this to the other side, and this one is the change in momentum, which is now the initial. Then here we have the final. So we are saying that momentum before collision is equal to momentum after collision. And in this case, we are saying that there is no loss in momentum. So we can state now the law of conservation of linear momentum, which states that for a system of colliding bodies, the total linear momentum is conserved or remains constant, provided no external forces act. And these bodies must not be 2. They can even be more than 2. For any system of colliding bodies, the total linear momentum remains constant. That is, the initial momentum is equal to the final momentum, provided that no external forces act on that or on those bodies. So we state the law of conservation, the law of conservation of linear momentum. The law of conservation of linear momentum states that the law of conservation of linear momentum states that for a system of colliding bodies, the total linear momentum remains constant, or it does not change, remains constant, provided no external forces act. So that is the law of conservation of linear momentum, whereby we can see when two bodies collide, we are able to see that the force exerted by one on the other is equal to the other force that will be exerted by the other body on the other one, but in opposite direction. And therefore we are saying that the impulse therefore will be force times time. So for the first body we'll have force times time. For the other body now the force is in the opposite direction, so we have negative if we take one direction to be positive and the other one negative. So when we add these two, we get 0, meaning that the total initial momentum is equal to the total final momentum, because we are saying that momentum, the change in momentum is simply equal to the impulse, and therefore the total initial momentum is equal to the total final momentum. And that is what we are calling the law of conservation of linear momentum. And we have seen that this can apply for any number of bodies, provided that there is no external force that is acting on those bodies. So for a system of colliding bodies, the total linear momentum remains constant, provided no external forces act. And that's what we are calling the law of conservation